All right, so let's just focus on this question. The question is asking me to calculate the mass of NaCl, okay, that is produced when you have these grams of sodium and chlorine. Put in your mind and just like put the red flag once you're given the amounts of the two reactants. However, let's just like look here. You're given 4.5 grams of sodium and you're given 6.75 grams of chlorine. Once you're given the amounts of the two reactants, this is a red flag to calculate the limiting reactant. And the limiting reactant actually is a reactant that is used up first during the reaction. So once it's used up during the reaction stops. Okay? So what are the steps of calculating the limiting reactant? Because we're going to relate the moles of the limiting reactant to the moles of the product that we need to calculate. So how can I determine the limiting reactant? All right. So the first step here, you have to change, or let's say you have to calculate the moles for both reactants. For here, you're given the masses for both reactants. You have to divide them over their molar masses. At this point, we have to divide over 23. And at this point, just like put in your mind, we ignore the big number here and we do not include it in here. We do not include it in the molar mass. We just take the number of molar mass from the periodic table. No need to put these big numbers in your calculations at this point. And we divide for Cl2, how many chlorine you have? You have 2, and then you have just 2 times 35.5. The moles of Cl2 are equal to 0.0951. And the moles for sodium are equal to 196. Now you have the moles. Okay, this is the first step. The second step is making ratio 2 times. We're going to make a ratio 2 times. All right, so the first ratio between the first reactant and the product, and the second ratio between the second reactant and the product. So let's go. How many moles of Na you have? You have 2 Na with respect to 2 NaCl. How many moles of Na you got? 0.196. And you don't know the moles of NaCl. All right. You just make a calculations. You multiply these two numbers and divide them over 2. X equal to 0.196 times 2 over 2. Then the moles of NaCl, the possible moles of NaCl are equal to 0.196. So this could be the first probable answer. We didn't finish. We said that we have to make a ratio between the two reactants with respect to the product. All right, so let's go to the second ratio. Okay, you have 1 mole of Cl2 and it gives you 2 moles of NaCl. How many moles of Cl2 you have? 0.0951, and here you have X. Then the moles of NaCl are equal to 2 times 0.0951 over 1, and then the answer is equal to 0.1902. All right, so you have 2 possible answers. Now it's time to determine which of these reactant is the limiting reactant and which of these you have to take their moles and ignore the others. We will compare the moles of NaCl. In both cases, we could have this number or this. So which of these is less than the other? You can see that this one is less than this. So we ignore this. We don't take it at all. We ignore it, and that's why Na is not the limiting reactant, but actually it's an excess, which means it's an extra. So let's go and take the moles of NaCl here, and you have to put in your mind the limiting reactant is Cl2. Great. Now I have the moles of NaCl. I'm so happy. But if you go to the question, it's asking you about the mass of NaCl. So we didn't finish. You have to do another step. The mass of NaCl is equal to 23 plus 35.5. And then the answer is equal to 11.12 grams of NaCl. So guys, you have to put in your mind, when to use the red flag in this case. Once you're given the amounts of the two reactants, you have to calculate their moles first and then compare their moles with respect to the products. And then, like if they're asking about mass, you have to multiply with the molar mass.